So as I was saying, the typical life cycle of testing with Kasich, puts performance testing earlier in the development cycle, starts with the developer using Kasich locally. Maybe you're writing a new piece of code, you want to test it. You're running a test against that locally, against what you have in your local environment, maybe just exporting or outputting those results into the terminal window. As it moves closer and further down the line and closer to production, maybe you run a larger test. Again, you run it locally, you output it to insights, you start to get some baseline data for what's happening. And then once that code starts to hit staging environments, or for the unlucky ones where production is their staging environment, you start to scale up and utilize Load Impact's cloud infrastructure to run larger tests. So this way you don't have to worry about organizing and synchronizing all these different servers and load generators. The cloud execution is currently in beta, but when it's released, it will allow you to easily scale to thousands of users across multiple load zones. Any users of our current product, it'll be very similar to that. Basically, take advantage of our infrastructure in the cloud. That all said, whether you're running tests locally or in the cloud, you can get your results back in Insights, and you can compare your test results between the two. Your analysis trending between test runs, whether those tests have passed or failed, and then of course sharing those tests with other team members or management that may want to look at those test results. Moving on, so downloading Kasich. So if you don't have Kasich, you can go out and get it. It's available. You can go to kasich.io. That's the project page for Kasich. Then head over to our GitHub repo. Depending on your platform and what your needs are, there's a few different ways to install. With Mac, you can install it via Homebrew. We have some pre-built binaries. You can install it into a Docker container or just build it from source. Really just depends on what your needs are. If you're having any trouble, reach out to us through the support team, or just join us on Slack and start to ask questions. We're happy to help you there. All right, so moving on, let's just quickly overview Kasich scripting, and then we'll go over a Kasich script and then run a test. So as I mentioned before, scripting is done in JavaScript. When looking at our current product, we felt it was necessary to use a more common scripting language. So any users of our current product, they know scripting is done in Lua. The amount of people that know Lua versus JavaScript is huge. So we said, hey, let's use something more common that developers will definitely be familiar with. In Kasich, it currently supports HTTP protocol. It also supports WebSockets. Our goal is to build some more protocols later on and support more things based on what the community is looking for, but that's what it supports right now. When you're writing your scripts, you can certainly script them by hand, but Kasich also has a built-in HAR converter. So all modern browsers are able to export a HAR file. You can basically browse like a user would, export that HAR file, and then just convert that using the convert command right from the command line. Some things to kind of just remember when scripting in Kasich, your journeys and test cases they're expressed as code. So that said, you can do programmatic things, generate random numbers, parameterize data, go grab a piece of information from somewhere and reuse it, whether it's in the response or whatever you may need there. Scripts can also start to become custom modules for common actions that you're taking. So examples of that, maybe you're always logging in, you're always getting data from somewhere. If it's a common thing that you're needing to test, you can kind of build that as a custom module. And then you can start to share that with other members of your team. An example, some of our early adopters of Kasich, they've started to build out those custom libraries, and it makes performance testing easy for new developers that they're hiring to start performance testing. Hey, all these things are written for me already. I can test this thing that I'm building myself. All right, so we're just talking about scripting, so let's look at an actual script. So just showing the code here is because I do want to call out some important parts of the script and kind of what to look for. So right at the top, just starting from the top, we're importing some things. The HTTP module contains functionality to make HTTP requests, so pretty important to include that. Kind of just going down, right after that on line 2, we have some functional models, checks, which are basically asserts. Groups are just a way to organize data in a test. So think of it as a page or a set of actions you want to group together and look at all those requests and response times as a whole. Sleep, so we can tell the virtual users to go idle or not make any requests during the test to make them more realistic and kind of pace them. And then finally, right below that, we import some metrics things. So a counter to count things. These are all tied to custom metrics, rate, and trend. Going down into that second box there, some global options for the test. So all these things are global in scope and lets us to define our test configuration itself. First, we have stages. So this is your ramping patterns, how you can ramp up and down to different levels of concurrent users in a linear fashion. Next, we have our thresholds, which are binary pass-fail metrics for a test. So if these evaluate to true or false, we can pass or fail a test. Failures would result in a non-zero exit code to being returned. And then finally, extension. So basically extending Kasich to the load impact cloud service. First, we give the test a name. That tends to be pretty important and useful when trying to look at results. And then that second item there, distribution, down on line 20. This test is capable to run in the load impact cloud on our cloud infrastructure. So this would just be how we would distribute the virtual users if we ran this test in that execution mode. This would only apply if we specifically passed Kasich Cloud when running our test and had valid access to cloud testing. Oh, I'm sorry. And then the final thing down here are on line 29 and 31. That's our custom metrics. So basically, I'm just instantiating some variables for custom metrics in our script. Custom metrics can be any numeric value. Here I'll be counting successful logins, a failure rate, as well as the trend of time to first byte over time. Again, these are all global in scope, so they'll apply to our entire test. Moving on to the main function, this is, I guess, the proverbial place where all the magic happens. This is where we make our requests, we group our requests together, we can calculate those custom metrics, and also evaluate our checks. The first group up top here, or in this first box up top here, you can see I have my front page group. So I'm just organizing all the requests here into this concept of a front page. Since this is a website test, it makes sense to call it front page. You may have a need or a reason to group things differently, and you're certainly welcome to do that. I want to quickly call out the next kind of if statement you see here. When I run the test, I'm going to be passing an environment variable. That's so I can force a performance alert to show up. So there's other use cases for that, but that's why this if statement exists and kind of what I'm doing there. Otherwise, this is just the main HTML document of the page. Next, as we move into the second box here, these are my checks. So they're asserts. I'm evaluating what's happening on this response. I'm checking to see if the status code is 200, if the body is 1,176 bytes, and if the welcome header is present. That immediately ties into what we see on the next few lines. So I record check failures. Any of those checks have failed, I add that to a custom metric. One of my thresholds is evaluating my check failure rate. So that's how I can kind of tie these failed checks into a threshold, which could eventually pass or fail a test. So I'm checking the failure rate of these checks, and then I'm also calculating the time to first byte and recording that. We'll also note I'm tagging this. I'm tagging the time to first byte for improved filtering in our results, and we'll look at that once we get to the test results. Finally, down at the bottom here on in the fourth box, I have a subgroup within this front page group called static assets, and just making requests to load those static assets. Again, run a check to make sure the status is correct. I record any failures and then calculate my time to first byte. So I continue to move on here, and I won't go through this kind of line by line, but just want to show that the general pattern starts to repeat here. So this is a second page, or a login page. We can see its name is group login. And it just represents a page where I'm logging in and then passing login details. If I were to parameterize data and want to make this test more dynamic, the post on line 91, this is where I could do some scripting to do that, to call a variable from some data set I have of different usernames and passwords. When I'm making my test cases and scripts dynamic, that's going to give you more realistic results. Maybe you even have a limitation on whatever you're testing. Hey, the same user can't be logged in, so you need to parameterize data here. So this is kind of where you would do that and where you'd start to do that scripting. That all said, it is up to you how you want to group things based on what your business need is. This is a website test, a very simple website, so it makes sense to have some different groups for a front page, a login page, and then that subgroup for static assets. Depending on what you're testing, I'm sure you can come up with different reasons to group things together. So now that we went over kind of the overview of what's of a script and kind of what's in there, let's look at how we can start to run tests. If you've started a trial of Insights already, or you're currently a paying Insights customer, you probably know all you need to do is pass the -o cloud command when executing your Kasich script. If you're neither of those things, it's easy to get started with the trial of Insights. Just head over to loadimpact.com/insights and you can get started there. We'll share that link again later, and then in a follow-up after this webinar, so you have it. So don't worry about going there right now. Before I start a test, just want to give a high-level overview of what we're going to look at, just some navigational things. So just want to quickly call out some key things about results. So at the top, we're able to easily see the different test statuses. So we can see if this test is passed or failed, or what the current status is. In this case, this is a pass test. I can tell since my status bar is green and it is in the finished state. Below that, we have a performance overview. It's just a summary of what has happened during a test, response times, number of virtual users, and then the status of our thresholds, checks, and requests. If I had any performance alerts showing up, that would show up in this section right below. In this case, I don't, but we'll see that in the test I run. And then finally, all the raw data would be down at the bottom if you wanted to dig into a specific request, a specific group, or looking to something that's important to what you're testing. All right, so let's check out Insights. Let me back out of here, open up my terminal. So I have an account with LoadImpact already. I'm already set up. If I wasn't already logged in here through the terminal, it's easy to log in. I could just Kasich login cloud, and that would prompt me to use my username and password for LoadImpact to log in. Since I am logged in, no need to do that. So for the purposes of this webinar, I'm going to pass an environment variable, and that's this URL alert equals 1. And this will trigger my test to go through some logic to generate a lot of URLs. So that's why I'm passing this here. Possible use cases that I've seen other users use. Maybe you want to create one test script and you want to run that against different staging environments, or staging versus production. In theory, you could pass some type of environment variable there to determine what environment the test is going to run against. So just a use case you might be interested in. So I pass this variable, Kasich run -o cloud, and then my script name. Just hit enter. So what this is going to do is start our Kasich test run, right in the terminal window, we're going to see some informational things. So we can see execution mode. This is local execution. The outputs to the cloud, our script name, max number of virtual users. We can also see total duration and current status. So I'm just going to follow this link here, which will bring me right to my test results. And we can watch them kind of come in and what's happening in real time. So this is a graphical representation of what's happening in those results coming in. A little bit prettier to look at than the terminal window, just waiting for it to return something interesting. So at the top, I mentioned we have the performance overview. 3 metrics that we plot right away. So active number of virtual users, the request rate, and then response time. The response time is an average response time for all requests in the test. Next, we have just some status on our thresholds, checks, and URLs. All three of these will be completely evaluated at the end of the test for whether they've passed or failed. Thresholds can pass or fail a test completely, so that's probably the most noteworthy or important thing to consider. Failed thresholds, as I mentioned before, that'll result in a non-zero exit code, so this is extremely useful if you're automating tests in a CI pipeline. Failed thresholds exiting in that fashion is true for both local and cloud execution, so you can use these to really set your tolerances and help to automate your performance testing. As I mentioned, performance alert, that just showed up. So here's a performance alert that, hey, we're running a test with too many URLs. There's too many, that looks weird. We'll dig into what that exactly says a little bit later. But as we detect these things, our built-in algorithms detect these things, I should say, we'll pop up these different types of performance alerts. And really the goal of those there is we want to help you get to the interesting information faster so you can make the right decision based on the test that you're running. As I scroll down, we have some filters here. So I can change the aggregation of my results, mean, max, different percentiles, again, based on what your business need is and what you find interesting or what your goals are. You can change the view here. We can also filter by tag. So I can filter by method, name, here's my group static asset, status code returned, my time to first byte URL. So different ways to kind of filter down and get to the information that you find interesting and important faster. So during your script, if you're tagging things and that are most important or most interesting, this will help you find them faster. As we go down into the breakdown tree, the breakdown tree is going to follow the vertical structure of the script. So our thresholds and custom metrics are right at the top, since they are global in scope. Then we follow that up with our different pages. So our front page, then our login page. If I were to go to this front page here, and actually that's going to open up a pretty big piece of data since I have so many unique URLs. We'll see the breakdown of all those URLs that are being requested. So why don't I take URLs out? I can see front page, our checks and kind of what they're doing, and these are passing. I can also see our static assets, and then again my check on that status set, my check on that static asset. As you analyze results, you'll probably have a good idea of what you're looking for. So kind of all these features combined to help you get to that data quicker and faster. If I click into this login group and I want to minimize my front page since there's a lot of URLs there and it's hard to parse through that, but I'll click into this login page here. So maybe for the purposes of this test, I'm testing the login. I want to make sure that the system that I'm testing can withhold or withstand the amount of users I have logging in. I can click on this URL, get some response times metrics, see how that's performing. I can see the status code being returned, and 99% were 200. And we have some failures, but only 2, so not too concerning in my view. If I wanted to dig deeper into this request, and click on these 3 dots over here, maybe I want to evaluate the different response timings. I can add that in here, and now I can see how long we've spent waiting, receiving, sending, TLS handshaking, all these, this further breakdown of this individual request. If I slide out our little analysis window, I can also add this into our analysis tab. So I can use this analysis tab to start comparing and correlating things, again, that are interesting to me or important to what it is that I'm testing. We can also add request rate and things like that into there. We can also add into our analysis the information about our checks, or our custom metrics rather. So basically all the data that you have here is available for you to kind of dig into and correlate. So you can help determine where those performance problems exist so you can get to them faster. So as I scroll back up, this test has finished. So we can see that, hey, we have passing checks and URLs and some information on thresholds. I can also see I have a performance alert here. So this is probably the most interesting thing about this test here is this performance alert. If I expand this, basically, hey, we're saying that, hey, you're requesting a lot of unique URLs in your test. And in so many words, having that many unique URLs is going to make parsing through the information in the result data set harder. Here's a recommendation on how you can improve that within your script itself. So I guess just to recap here, for this test, what's interesting? Not a whole lot. This is a very green test, but not all tests are going to be as green as this one. That said, it is important to set up thresholds and checks to help define those tolerance levels within your script and what you'll ultimately be testing. When those are properly defined, you can use them to, or help use them to leverage insights to pass or fail those tests based on what those tolerance levels are. And all in all, that helps you take the whole process of performance Q&A to the next level by including it within those CI and automation pipelines. So if I were to recap real quick, kind of what's important when looking at a test, you obviously want to look into your checks and thresholds, make sure those are at acceptable levels or within whatever your SLAs are. You should then look to your URLs and groups, look for large variances in any of the response times. Hey, if there's a URL that has a minimum response time in milliseconds, but a maximum in seconds or minutes, that's an interesting data point to look at. You should also dig into the groups to see what pages users are running into potential performance issues. Kind of what you do with this data and where you take it, it almost turns into a choose your own adventure based on what's important to you and kind of what you learn from the test result. But I guess ultimately tying it back to whatever those SLAs are and what those important individual requests or services are, that's where you'll want to ultimately start with results and associating those thresholds and checks with those different things. So that said, let's go, or before I do that, we can also just to show you in our terminal window here, we can see we have our test is finished. We can see our different checks. We can see that some thresholds have failed, and then just overall data about the test. So as I go back to my presentation here, just want to give some information before we do Q&A, how you can learn more about Kasich and insights. So Kasich.io is our is our project page. You can go there, get all information and documentation about Kasich, the open source load generator. I also encourage you to join our Slack team. Community is very active in there, so come in, ask questions, talk about a unique use case you have. We love to hear those types of things. You can follow us and kind of check the project out on GitHub and submit an issue, fork it, engage with us there. We'd love to hear what's important to you and what you want to start to load test. For everybody that wants to check out insights and streaming those results into Load Impact, you can start a free trial at loadimpact.com/insights. And for any questions about insights and I guess Load Impact in particular, you can reach out to us at support@loadimpact.com.